All right, 8th grade math, we are doing 12.4 today, the converse of the Pythagorean theorem. The good news is the Pythagorean theorem stays the same. It's just a different way of using it, but I think you'll find it very intuitive. It will be logical and make sense to you. So remember that the Pythagorean theorem tells us that in any right triangle, remember that's a key word, it has to be a right triangle. Oh, it doesn't want to let me write. Let's try again. There we go. In any right triangle, the sum of the squares of the lengths of the legs, so A and B, is equal to the square of the length of the hypotenuse, which is C. So we would say if triangle ABC is a right triangle, then A squared plus B squared equals C squared. So now we're going to talk about the converse. We would say the converse is also true. So if we say it the other way, if the sum of the squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right angle. So before we led with the idea that we had a right triangle. When we state the converse, that's the conclusion that we draw. So that's the only difference, is the order in which we state it. We're reversing kind of the argument and the conclusion. So we would say if A squared plus B squared equals C squared, then triangle ABC is a right triangle. So if you compare this summary statement with this one, you can see how the converse changes what we're saying. So here's how we're going to use it. Are these triangles right triangles? Justify your reasoning with math. When we say justify, we mean give me your reasons, prove it, tell me how you know. So here's my triangle. Obviously it's not labeled a right triangle, but I'm going to decide if it is a right triangle by identifying this is the angle under question, right? This is the one that we're thinking could be a right angle, but we don't know for sure. That still makes this, oh, give me my pen back. There we go. My hypotenuse, or my C value. So I'm going to make my shortest side A, and we'll call this our B. So let's use our Pythagorean theorem, A squared plus B squared equals C squared, and let's find out if this makes a true statement. So A is 6, B is 8, and C is 10. I've started by writing my formula, I substituted, now I'm going to simplify. So 6 squared is 36, 8 squared is 64, 10 squared is 100. 36 plus 64 is 100. 100 equals 100 is a true statement. So we would say, yes, triangle ABC is a right triangle because A squared plus B squared equals C squared. Let's check this one. This would be our angle in question right here, right? This looks like it could be a right triangle. So since this is the side across from the right angle, or the possible right angle, this would be our C value. So I'm going to make the smallest side my A, and this medium size my B. Let's check it out. Does A squared plus B squared equal C squared? I wrote my formula, now let's substitute. A is 4, so 4 squared plus B squared, which is 5 squared, equals C squared, or 6 squared. We've substituted, now let's simplify. 4 squared is 16, 5 squared is 25, 6 squared is 36. When I add 16 and 25, however, I get 41. 41 does not equal 36. So I can prove that this is not a right triangle, because if A squared plus B squared equals C squared, then it is a right triangle, and if it is a right triangle, then A squared plus B squared has to equal C squared. In this case, it does not, so we can conclude that it is not a right triangle. Let's try another example. All right, this would be the angle that we are guessing could be a right angle. So that makes this my hypotenuse, or my C value, because it's across from my potential right angle. My shortest side here is A, and my medium length side is B. So let's use our formula, A squared plus B squared equals C squared. Now let's substitute. So I'm going to put 2.5 in for A, 6 in for B, and 6.5 in for C. Okay, so as we simplify, 2.5 squared would be 6.25. 6 squared is 36. And 6.5 squared is 42.25. So as I add 6.25 plus 36, I get 42.25, which is equal to 42.25. So I could say yes, this is a right triangle because A squared plus B squared equals C squared. All right, in your notes, you can try this last one on your own and record your answer in Edpuzzle to check your work. So even if we are given side lengths without the actual picture, we can still do the same process because we know that our hypotenuse is always going to be the longest length, and usually we'll call our shortest side A and our medium side B. So if we write our formula, A squared plus B squared equals C squared, and then I substitute 9 for A, 12 for B, 15 for C, and now I simplify. 9 squared is 81, 12 squared is 144, 15 squared is 225, and if I add these, then I should see if this represents a right triangle or not. 81 plus 144 does equal 225. So 225 equals 225 is a true statement. So we would say that yes, this represents a right triangle because A squared plus B squared equals C squared. Let's try on this second set of side lengths. So again, my smallest will be my A value, my medium will be my B, and my largest will be my C. So let's write our formula. A squared plus B squared equals C squared. Next we substitute 10 for A, 15 for B, 20 for C. Then we simplify. 10 squared is 100. 15 squared is 225. 20 squared is 400. And I can tell right off the bat this one is not going to work out so nicely because 325 does not equal 400. So we would say no, this is not a right triangle. And let's check this last one to be sure that we've got the hang of it. 3.5 is going to be my shortest side, so my A value. 12 will be my B, and C will be 12.5 because it's my longest. So let's write our formula. A squared plus B squared equals C squared. Now let's substitute our values. 3.5 for A, 12 for B, 12.5 for C. Okay, so next step is to simplify. So if I have 3.5 squared, then that simplifies to 12.25. 12 squared is 144, and 12.5 squared is 156.25. When I add 12.25 plus 144, I get 156.25, and that does in fact equal 156.25. So we would say yes, these side lengths describe a right triangle because A squared plus B squared does equal C squared. All right, last section. Same idea. just using some square roots as side lengths this time, which is new for us, but we're going to do the exact same thing. Nothing changes. We're going to test with a squared plus b squared equals c squared. So my side opposite the right angle is going to be my c. We could call this one a and this one b. Doesn't really matter. Usually a is our shortest value, but these are both legs, so it doesn't really matter which one I label a and b. So now let's substitute. So I'm going to do radical 15 squared plus radical 21 squared equals 6 squared. Radical is another way of reading the square root bar. It's the way you'll refer to them in algebra. So when I say radical 15, it just means the square root of 15. Now if I take the square root of 15 times the square root of 15, I'm going to get 15. So when I take the square root of a number and then square it, remember that the square root bar and squaring a number, those are opposites. So those undo each other and they cancel out. So all I'm left with is the number on the inside. So radical 15 squared is 15. And radical 21 squared is 21. Now over here I don't have a radical, I just have a whole number squared. So 6 squared, 6 times 6 is 36. Now I need to see, is 15 plus 21 36? Indeed it is. So we would say yes, this is a right triangle. And we can justify it because a squared plus b squared equals c squared. If that's true, then triangle ABC is a right triangle. Your turn to try this example in your notes and enter your answer in Edpuzzle. I know you will do great. When you finish up, your homework is 12.4 in digits.